Assalamualaikum and very good day to everyone, especially to our lecturer Dr. Suzari bin Daud. I'm going to introduce myself and my team member. My name is Nofarah Nadia binti Zakaria and my metric number is A20SC0234 and my team member is Akidah binti Muhammad Noor with metric number A20SC0025. So today our group will present the whole process of E3 experiment, which is light emitting diode LED. Before that, I'm gonna explain to you background information about LED. Firstly, symbol and construction. It is a two-terminal device which contains P-N junction. The two terminals are namely the cathode and the anode. Manufacturer indicate the anode by keeping it longer in length as compared to the cathode. And how it works? During forward bias, the electron from N region cross the P-N junction and combine with hole in P region. The electrons are at the higher energy level than the hole, and this energy difference result as the visible light. During combination process, the electron release energy in the form of photon. The objective of this experiment is to measure the differences between red LED and green LED. Second, to display numbers using 7-segment display. There are several equipment needed in this experiment. First, variable DC power supply, project board with connecting wire, digital multimeter, resistor 270 ohm with 0.5 watt, diode 1N4007, red LED and green LED, and lastly 7-segment display. I am going to talk about procedure of part 1 experiment. The available red LED was inspected. The anode and cathode lead were identified. The circuit was connected as shown in the figure 1. The voltage Vs was adjusted until current of 10 mA flows in LED. Then, the voltage was written down across in table 1. Vs was adjusted to obtain others value of current listed in table 1, and the table was filled out. This is the result obtained for part 1. For the part 2, the red LED was replaced in figure 1 with a green LED. Step 1 to 5 were repeated in part 1, where the voltage Vs was adjusted until current of 10 mA flows in LED. Then the voltage was written down across in table 1. Vs was adjusted to obtain other value of current listed in table 1, and the table was filled out. This is the result obtained for part 2. For part 3, the pin of common emitter 7-segment display was shown in figure 2. The circuit was connected as shown in figure 3. The type of SSD used, common cathode or common anode, was identified. Based on figure 4, the pin that should be ground to display 0 was determined. Next, the pin number was written down in table 2. Step 3 was repeated to display other number of listed in the table 2. And this is the result obtained for part 3.
Assalamualaikum and hello everyone, especially to Dr. Suzari bin Daud. I would like to introduce myself. I'm Akidah binti Muhammad Noor and I will continue the presentation on part 4, which is answer the question. So for the question 1, it asks for our comment on the LED brightness when the current is varied. Based on the experiment, our comment on the LED brightness when the current is varied, the brightness of the LED is directly proportional to the current. Thus, when the value of the current was increased, the brightness of LED also increased. Next, for question number 2, it asks us to estimate the current through the 270 ohm resistor if the number 8 is displayed. So for the first step, we need to find the current flowing through one LED. Then we use the formula V equals to IR. For the voltage, we calculate the average of red LED voltage, and we got 2.29 volt. After that, we rearrange the formula V equals to IR, and we got 8.48 times 10 power of negative 3 ampere. That is the value for the current flowing through one LED. For display number 8, 7 grounded pin number was needed. Then we need to estimate the current for number 8. We use the value of current flowing through one LED times with 7 because there's got 7 grounded pin. Then we got 0.059 ampere. So if current number 8 is displayed, the current through the 270 ohm resistor is 0.059 ampere. So for number 3, it asks for our comment on the differences in the brightness of number 1 and number 8. If there's any differences, give reason. So there are differences in brightness regarding number 1 and number 8. For number 1, it's much brighter compared to number 8. This is because for number 8, more jumper wire were used to connect to grounded pin number. Therefore, the resistance in each jumper will build up, causing the number 8 to be less bright compared to the number 1. The last question is number 4. It asks for our suggestion of any modification to produce the same brightness. So, to produce the same brightness, we have to put resistor at every anode. Next, I will talk about the discussion on this experiment. So, based on the experiment on part 1 and part 2, we can see that the voltage for green LED is slightly higher compared to red LED at the same value of current. As we know, wavelength of red color is longer than green color. For the red color, the wavelength is 650 nanometer, and for the green color, the wavelength is 550 nanometer. Therefore, the longer the wavelength, the lower the voltage required. And this is because the photon that is needed to interact with the semiconductor need to have more energy. Besides, based on part 3 on this experiment, it is obvious that the type of 7-segment display that we used was common cathode. The brightness of each number was varied as each number needed different grounded pin numbers for the numbers to be displayed. Apart from that, it is clear that the more grounded pin numbers, the dimmer the number that was displayed. There are few factors that affect the result of the experiment. So firstly, the sensitivity of the current source and it is easily moved and might be having false reading. So for the precaution, we need to pay attention towards the smaller scale of the current source and slowly tune it for accurate reading. The second one is error due to effect of the cell current. Heating effects of the wire leads to thermal expansion in the wire. So, due to the thermal expansion, the resistance of the wire increase. To minimize the error, we need to switch off the circuit after every reading. Last but not least, I will talk about the conclusion of the experiment. So, first, I already determined the difference between red LED and green LED. So, in the part 4, I already calculate the average of red LED voltage, which I got 2.29 volt. And now I calculate the average of green LED voltage, and I got 2.06 volt. Then, I calculate the difference between red LED voltage and green LED voltage, and I got 0.23 volt. So, for the number 2, all numbers from 1 to 9 and decimal point were displayed using 7-segment display. And the last one is the references. I got 2 references from Google. So, that's all from me and Farah. Thank you.